After launching a failed bid to buy OpenAI in the past 2 weeks, Elon Musk just released Grok 3 through his company xAI, claiming it's the most powerful AI model in the world right now. And if the benchmarks from the live demo hold up, he might be right. Grok 3 enters the growing field of reasoning models, competing with the OpenAI O series of models as well as with DeepSeek R1. However, it looks like xAI is positioning Grok 3 as both a reasoning model and a generalist AI, with the ability to turn on and off deep thinking mode as well as deep research mode, and we'll come at that shortly. So in this video, we'll be putting Grok 3 through its paces, testing out its reasoning and research capabilities. Now, my objective with this video is not just to provide an overview of Grok 3, but to provide you some perspective and intuition over how reasoning models operate versus traditional LLMs. So even if you're not planning on using Grok 3, I'm hoping that you get value from this video. Before we get started, this video is brought to you by DataCamp. If you're new to DataCamp, DataCamp is a data and AI skills transformation platform that allows you or your team to build your data and AI skills whenever and wherever you want. Whether it's interactive courses on topics like Python, the OpenAI API, LangChain, the Meta Llama stack, and more, the ability to pass key technology certifications with specifically designed tracks, or the ability to go beyond learning with DataCamp Data Lab as well as unguided projects. You can test out DataCamp for free in the link in the description below. Okay, so with that, let's get started. And I want to start by taking a step back and see how we got here. For the past few years, the dominant approach for improving LLMs has been in scaling, simply making models bigger by increasing compute, the data they're trained on, and the size of the models themselves. The strategy follows a well-documented path. The more you scale up, the better performance you can expect across a variety of tasks. And the scaling paradigm showed that by just adding more compute and more data over time, you can expect models to become better at out-of-context tasks, and this was called emergent capabilities. But over the past 12 months, scaling hit a wall, and many AI thought leaders and researchers started sounding the alarm about how we're reaching a plateau in intelligence despite adding more compute and more data into training these models. Just making models bigger wasn't enough to solve complex reasoning tasks. So instead, the focus started shifting to a new paradigm, which included the following. Number one, test time compute, where instead of throwing more data and more compute at the pre-training phase of a model, researchers began looking at ways to provide models the ability to think at the inference time, meaning at the time where they generate a response, so that they're able to reason step by step when creating a response rather than generating a response in one go. Number two, reinforcement learning, where models use reinforcement learning to plan efficiently and effectively the best solution for a complex task. Number three, reasoning-focused architectures, where on top of the transformer architecture we usually see in large language models today, researchers also began incorporating tree search, chain of thought prompting, and additional planning mechanisms to help models reason better. Now, I don't want you to drown in jargon, so I'm going to simplify this with an analogy. Imagine you're preparing for an exam, and there are two ways by which you can go about this. Number one, memorize everything and hope that whatever you get in the exam is something you've already seen before. And number two, become so good at the subject matter and learn how to reason through it that even if you get a new problem, you're able to break down that problem step by step and think about it and reason through it and hopefully solve it even if you've never encountered it before. The scaling paradigm we talked about earlier looked a lot like that memorization strategy. The good thing about that paradigm is that models are really effective at tasks that they've seen before and are really fast at answering them, but they're not so good at complex tasks or tasks that they've never seen before here. The current inference scaling paradigm looks a lot like that second study method, where you learn the subject matter so well and learn how to reason through problems that you're able to solve complex tasks that you're not necessarily used to. The good thing about this approach is that you're flexible, you're able to solve different types of problems, even if you've never encountered them before, but you're slow, and it takes you a long time to be able to find the solution. So coming back to the topic of the video, Grok 3 is arguably the most cutting-edge reasoning model available today, so let's put it through its paces. So here I have the Grok 3 interface open. All you need to do is go to grok.com, sign up if you haven't signed up, and you'll be able to access Grok 3. You'll be able to choose the model here. So this is the Grok 3 model. It's in beta at the moment, and Grok 2 is the previous generation model. So I'm going to keep this at Grok 3. And as you see, you have these three toggles. One, the ability to add attachments. One, the ability to turn on deep search. So this is the ability to do deep research on a topic. And then the ability to turn on think, right? So the ability to let the model take its time, as well as the breakdown step by step, which is that reasoning model framework that we just discussed previously. So I'm going to first test out some of its reasoning model capabilities. And the first thing I'm going to do is I'm going to give it a bit of a logic question, which is use the digits 0 to 9 to make three numbers, x, y, z, so that x plus y equals z. And what this does essentially is Grok needs to come up with three numbers, x, y, and z, that use unique numbers. So it cannot use the same number twice, so that x plus y equals z, right? So it needs to make sure that all of these numbers here contain these digits, 0 to 9. It cannot use the same digit more than once, and it needs to satisfy the constraint that x plus y equals to z. So with that, let's test out its capabilities and see what it does. And as you can see, the thinking is really, really fast. And it has this really nice interface that are quite as nice. So you can expand the thinking and see how it's the chain of thought traces. So I have this problem, right? Yada, yada, yada. And if I minimize this again, you'll see here that the thinking is taking on some time. So it's considering here different scenarios of how the x and y, z numbers can be set up. So the possible configurations are x and y both 3-digit numbers and z is a 4-digit number, or x is a 1-digit number, y is a 4-digit number, and z is a 5-digit number, or vice versa. Okay, it's coming up with a formula of how to think about it. So if I remove the traces here and I just keep it thinking, it kind of reminds me of DeepSeek the way it thinks, or it speaks itself. Well, wait, actually no, z could have 0 to so on and so forth. Okay, so it broke down the response here, right? And after thinking for 165 seconds, it gives me an overview of its approach. So to solve this problem using the digits 0 to 9, it's constructing a solution. Okay, interesting. So you can see here it's using a logical reasoning and step-by-step rather than approaching it randomly. So it came up one possible solution is x is 87, y is 5,934, and z is 6,021. So let me double check here my math. Okay, it is indeed equals to 6,021. And looking at x, it has the 8 and 7 number. Y has the 5, 9, 3, 4. And z has 6, 0 to 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 at the beginning. So it did solve it correctly, and it was actually pretty quick. For comparison, when we tested this on DeepSeek R1, it took around 270 seconds. And this is if you can use the DeepSeek R1 chat app, because you almost get server errors 8 out of 10 times. And I think on O1 as well, it took around a similar time. So definitely a good start here for Grok. Now, second question I'm going to do is I'm going to ask it for some coding assistance, right? So what I'm going to do is I'm going to have this problem here, and it's a bit of a pickle. It's not the most cutting edge problem in the world, but it does require some ability to reason through it here. Now, I'll go through the problem, and I'll first describe what's wrong with the function, so that we can pick up the answer. So people participating in a city had to write down their names when starting and ending the race. We know that exactly one person didn't finish the race. This Python function is trying to find out the name of that person, but it doesn't work. Fix it. So the function here is said, define and find person names. We count the frequency of the names. For name and names, if name not in frequency, it equals 0, otherwise it's +1. And then find the name that appears only once, right? So I'll explain why this function is wrong, right? So at the beginning of a race, right, the code, each person writes down their name, right, when starting and finishing the race, right? So the code here is trying to solve the problem by finding the name that appears only once. Each person completes the race will write their name twice, right? So while the one who doesn't complete it will only write it once. However, the code incorrectly assumes that all names are distinct. So here we see if frequency name equals 1, then return name, right? So the correct answer, right, would be to replace here the second loop to find the name with the odd frequency instead, right? So let's see how it performs, and then we'll take it from there. So it's trying to understand what the function is doing. It's trying to simulate names. Going back to the trace of thought here. Oh, I'm hitting my limit. So let's see what it came up with. I think it did not fix this. So let's fix the function find takes a list of names which contains all the recorded names. Each finisher's name appears twice, while the person who didn't finish has their name recorded. The goal is to find the name that appears only once. So here's the original code. The problem uses a dictionary to count how many times each name appears. For each name in the list, it checks the name that is not yet in frequency. So then it's just okay. It does have 3 names where Alice finished names it, but Bob didn't. Okay, no. So it did not take into account that people may have the same names. Now I have a third reasoning task, and then I'll be actually jumping towards a deep search task. So hopefully we will still be able to retain our usage limit. So the third one, so here it failed, right? So we have one prompt that it succeeded at, and one prompt that it did not. Let's do the third one, which is create something that I can paste into P5.js that will startle me with its cleverness in creating something that invokes the control panel of a Starship in the distant future. This is something from Ethan Mollick. This is not an original prompt. I stole this from Ethan, but I thought it was a really interesting prompt here. So I'll use it. And in the meantime, I'm going to open a editor of P5.js. Okay, so it's creating the different code. Okay, it's ideating. It's giving me the completed code here, so the thinking traces should stop and then give me the answer. Okay, so here. It's telling me to open the P5.js web editor. Let's see if we're opening. Oh, yeah, we're opening the same one. That's pretty cool. And it's telling me what makes this clever and startling. There's 3D and 2D integration. Okay, there's a 3D rotating sphere. The sphere spins faster as you increase engine power. So let's see if it actually has... Oops. I'm gonna run it. Okay. So, oh wow. Okay. That's actually pretty cool. Okay, so it doesn't necessarily look like a control panel of a Starship, but I'll give this some kudos. It's interesting, it's complex, it's not easy code, right? The one that impressed me the most on this front, we'll make sure to share Ethan's tweet where he compares other models in this. I think it was O3. O3 had a very nice vibe to it, right? But this is still impressive nevertheless. Yeah. So with that now, we one conveniently exhausted all of our think chats, but we also can start doing some deep search, right? And this is where I want to test out some of its deep research capabilities. So the first one will be the state-of-the-art LLMs, right? So we do a lot of research on what are the best LLMs. Let's do some tutorials on them. Let's do some YouTube videos on them. So what are the type of models that we should be aware of? So what I will ask here is, I want a clear and up-to-date summary of the AI ecosystems of the following model providers: Google, OpenAI, Meta, DeepSeek, so that is DeepSeek, Anthropic, xAI, and Mistral. So let's see how it performs. So it's loading a few pages, searching for the OpenAI ecosystem, searching for Meta's ecosystem. So the thing is, we'll see how it looks, okay? All right, so this is pretty well researched. Okay, let's see how it goes. Okay, so looking at the model here, let's go through the results. Google AI ecosystems, it's comprehensive, featuring so on and so forth. Gemini Pro, so on and so forth. OpenAI GPT series, GPT-4o, GPT-4 Turbo, ChatGPT and DALL-E. Meta's ecosystem, Llama 3, okay. DeepSeek, R1, they mentioned R1 and V3. Claude 3.5 Sonnet and 3 Opus. XAI, founded by Elon Musk, aims to accelerate human scientific the Grok series of models, okay. Mistral 7B, Pixel 12B. Detailed analysis, right? So here we have Gemini 2.0 Pro experimental February 2025. That's actually really good that it's able to get the latest model here. And then 1 and O3 mini with high intelligence ratings, right? Meta's ecosystem 3.3, right? DeepSeek AI ecosystem, okay, interesting. Anthropic, so we have R1, V3, output speed of 355, yeah, that's pretty good. XAI, such as Grok 3 and Grok 3 mini, announced in February 2025. And Mistral, same thing. So we do here key models, Google Cloud, Vertex AI, Gemini, Gemma 2, okay, O1, O3 mini. That's actually really good. For context, and we'll include this in the description, and we'll also show this on screen. The deep research function by the OpenAI model, right, in ChatGPT, was not able to find the latest cutting edge models, right? It was telling us about Llama 2. It was telling us about GPT 3.5 and GPT 4, right? So it was actually, this is actually quite impressive, given that this is an up-to-date, kind of requires you to be really up-to-date on your information, this type of query. And it was able to do relatively well. So I'm going to go here with deep search again, but this time I'm going to go with a more evergreen topic, something that like anyone would ask here, right? So here, I'm considering buying a car and weighing the pros and cons of purchasing new versus used. I've heard that new cars lose value quickly, but I'm unsure if this is always the case or just a common misconception. I just want to explore a different perspective on this decision, particularly from people with strong economic reasoning. Please provide a well-researched breakdown of the key arguments for and against buying a new car versus a used car. Include insights from economic principles such as depreciation, total cost of ownership, financing, insurance, and long-term value. If there are notable trends or studies on this topic, summarize them as well. And just for context, when we tried this on the ChatGPT deep research function, it actually performed really well. So we're using that as a benchmark. What's really impressive is just how blazing fast it is. Like if you think about that previous deep research function as well, query that we had took like what, 2-3 minutes tops. The same one on the OpenAI deep research tool, right, took around 10 to 15 minutes and had lower performance. Okay, getting different results. Long-term ownership, comparing our costs. I like how it breaks down the prompt into different kind of sub-prompts, right? Because if you look at our initial prompt here, I want these different perspectives. These are the different arguments I heard, so on and so forth. So it looks at trends first, retention, calculus depreciation, net cost, long-term ownership, economic factors, so on and so forth. Okay, so key points. New cars lose value quickly, often 20% the first year. Oh, wow. Okay, let's jump in. And 30 to 40% in 3 years. But some models like a Toyota and Honda hold value better. Used cars are cheaper upfront, depreciate slower, and have lower insurance costs, but may need more maintenance. Total cost of ownership can be lower for used cars, especially if kept long term, but depends on factors like maintenance and financing. And here we see an analysis here. Okay, so compared stable new versus cars. Okay, this is also for Toyota Camry 5-year ownership, for example. Interesting, interesting. So we have financial like Ramsey Solutions. Who is Ramsey Solution? I think this is Dave Ramsey. While some like wealth vendors, okay, interesting. This is actually a pretty well researched analysis, and again, it took 1 minute and 12 seconds, right? Which is quite interesting. And if I go here to my chat, right, this one took 52 seconds, and it had way better quality output than the OpenAI deep research function, which took 10 to 15 minutes or so. Um, okay. Ooh, unable to provide a, well, we'll give you a pass here because we got the response. Okay, so that wraps it up for these tasks here. Of course, we can put the model way more in through its paces, right? But it's definitely looking like Grok is up there in terms of the top LLMs and reasoning models that you can use today. So with that said, we tested out Grok 3. It's actually performing quite well and looks like it holds up to the benchmarks that were shared in the launch event. We'll see as we test out the model more and more so. What I'm excited for is the API. I'm looking forward to create a tutorial on the Grok 3 API and see how it performs and how we can build really interesting use cases with the Grok 3 API. But with that, it does look like the Grok 3 chatbot at least holds up to some of the promises made in the launch event. And definitely excited to test it out further. Let us know whether we're missing a few prompts, how you would test out a reasoning model to its full capabilities. What would you like to see in the next video? Let us know in the comments. We'd love to hear from you. And with that, happy learning.